Hey everyone, welcome to this explainer. Today, we're diving into something I find absolutely fascinating, a 4-year real-world case study on residential solar. We're not just looking at theoretical numbers here, we're looking at hard data from a 9.49 kilowatt solar system installed on a house right in Massachusetts. And you know Massachusetts, it gets seriously cold and definitely snowy. So if you've ever found yourself wondering if solar panels actually do what they promise in, let's say, less than ideal climates, well, you are completely in the right place. We're going to break down the real numbers, some pretty surprising challenges, and the ultimate financial payoff.
Okay, so let's get right into it. First thing you've got to know, this setup was basically the opposite of perfect. Seriously, if you're picturing that ideal, massive, south-facing roof soaking up rays all day, scratch that. This roof is small, it faces east to west, and to make things even trickier, there's a huge amount of tree coverage on the west side that literally starts blocking the sun by mid-afternoon. So yeah, we are talking about what you'd definitely call a bad roof for solar.
So you might be asking, why even bother with a roof like that? Well, the homeowner had 3 really specific goals. First off, they just wanted to lower those electric bills and save some cash over time. Second, they wanted to run on 100% clean energy as much as possible. And third, they wanted energy independence, specifically enough juice to charge up a Tesla Model 3 with power they made themselves. And honestly, the results are wild. Even with all those physical limitations, over the first couple of years, this system slashed the homeowner's reliance on the grid by a whopping 54%.
Section 1. The mystery production drop. When the numbers just don't add up.
Okay, so at first, things were going incredibly well. The system was tracking perfectly for a 7 to 8 year payback period. But then, year 3 happened. Out of nowhere, the overall electricity production from the solar panels dropped by a massive 11% compared to the year before. I mean, if you're the one relying on these panels to pay your bills, a sudden double-digit drop is exactly the kind of thing that makes your stomach totally drop.
Let's look at the exact numbers so you can see what this missing electricity really looks like. In 2020, those panels pumped out a really solid 7,293 kilowatt-hours of energy. But in 2021, that number slumped to just 6,479 kilowatt-hours. And add insult to injury, the homeowner was working from home, so their actual electricity usage went up. A sudden, totally unexplained drop like this, yeah, that's exactly the kind of data point that would make any solar skeptic say, aha, I knew it.
Which brings us to the biggest question, and it's probably one you've heard a million times. Do solar panels just degrade and die out after a few years? Like, is this 11% drop in year 3 absolute proof that the tech just doesn't last?
To figure that out, we have to look straight at the hardware specs. The system in this case study uses really high-quality LG panels, and these panels guarantee a maximum efficiency loss of just 0.5% per year. In fact, even after 20 years, they are mathematically guaranteed to keep at least 88.4% of their original efficiency. So here's the absolute crucial takeaway. A massive 11% drop in a single year literally cannot be a hardware degradation issue. The panels weren't broken, so what on earth actually happened?
Section 2. Weather versus panel degradation. Uncovering the real culprit behind the drop.
Now, we all know day-to-day weather makes your solar production bounce up and down. But to solve a massive year-over-year mystery like this one, we've got to zoom out and look at the macro trends. And guys, this is where it gets dramatic. When you overlay the historical weather data for New England in 2021 on top of the solar production chart, the connection is absolutely undeniable. 2021 was a giant outlier. It was actually the 3rd warmest and the 3rd wettest year on record, dating all the way back to 1895. Just look at July here. Normally, Massachusetts gets about 4 inches of rain in July. In July 2021, they got hammered with an average of 10.3 inches. Summer is supposed to be the absolute peak time for solar because of those long days and high sun angles, but all that severe, record-breaking rain basically blacked out the sun right when the system needed it the most.
But honestly, here's where the data becomes incredibly reassuring. Even with extreme once-in-a-century weather anomalies throwing everything out of whack, the historical modeling that the solar installer used was shockingly spot on. Listen to this. The installer predicted the system would generate 6,549 kilowatt-hours that year. The actual output, even with all that terrible rain, 6,479.6 kilowatt-hours. That means their long-term prediction missed the real-world output by less than 1%. It really goes to show that massive seasonal weather swings are already heavily baked into the conservative estimates your installer gives you.
Section 3. crunching the solar financials, the true cost of energy independence.
So while the panels were out on the roof battling record rainfall, the local utility rates were doing something crazy. They spiked aggressively for 24 cents all the way to 30 cents per kilowatt hour. And you know what that does? It actually makes the solar panels way more valuable because the power they generate is now replacing much more expensive grid electricity. Let's look at the financial pie here. After the federal tax credit, the initial cost was $20,727, but you aren't paying that all by yourself. First off, they have one-to-one net metering, which basically means the extra power generated in the sunny summer completely wipes out the bills in the fall. That's about $1,500 right back in the homeowner's pocket every year. Then, you've got solar renewable energy credits, or SRECs. The homeowner gets a check for $126.22 every single month for 10 years. That's an expected $15,146 total. When you factor those SRECs in, the true out-of-pocket cost plummets down to just $12,380. And here's how that all plays out on a timeline. We start over here at point A, the installation day. Thanks to those yearly electric savings and the monthly SREC checks, the system reaches point B in 2026. That is the magic break-even point where the system has 100% paid for itself. From 2026 on, the electricity is completely free. The warranty doesn't even end until point C, 20 years down the line, and the panels themselves should keep churning out power for 30-plus years out at point D. So once you cross that 2026 mark, guys, it's just pure profit.
Section 4. Panels and property value. The unexpected plot twist.
All right, so the math looks flawless, right? Well, here comes the major plot twist. The homeowner is not staying in this house until 2026. In fact, they're building a brand new net zero home and moving next year. That means they're selling the house right smack in the middle of the payback period. So the high-stakes question here is, did they just lose thousands of dollars? Does all that beautiful math go completely out the window if you move early?
Luckily for them, the data says absolutely not. When you slap solar panels on your roof, the real estate market treats it a lot like you just put in a high-end kitchen or a luxury bathroom. It actively drives up your home's value. And get this, the homeowner's insurance rates didn't even go up a single cent after they were installed. Zillow's real estate data shows that homes with solar panels sell for about 4.1% more. Plus, the National Renewable Energy Laboratory, the NREL, found that your home's value jumps by $20 for every single dollar you save annually on utility bills. Let's actually run the math using that NRL formula. We know the homeowner is saving $1,500 a year on electricity, right? Multiply that by 20, and you get a calculated bump in the property's value of $30,000. That massive chunk of home equity completely swallows up any remaining out-of-pocket costs for the panels. It means the homeowner walks away totally in the green, even though they're moving way before the break-even date.
Section 5. Is it still worth it? The final verdict.
Let's pull this all together. When you factor in the crazy weather, the spiking utility rates, the bulletproof hardware guarantees, and the surprise home sale, here's exactly where the homeowner stands today. The initial cost was $20,727. Over the past 4 years, they've already pocketed $6,000 in SREC payments, and they've kept another $6,000 in the bank from totally avoiding electricity bills. That leaves them with only about $8,000 left to recoup before they hand over the keys. But as we just saw, the house's value has likely skyrocketed by roughly $30,000 thanks to the panels. Looking at the raw data, this wasn't just a good idea, it was an incredibly sound financial decision that completely nailed the original goals of saving cash and running on clean energy.
Now here's what you really need to take away from all this. If you run the math and it works for your house, timing is literally everything. Government incentives are shrinking as we speak. Over in the US, the federal solar tax credit is set to drop from 26% down to 22% in 2023. And on top of that, thanks to supply chain hiccups and massive demand, the really good solar installers are booking up months in advance. Our homeowner here is already finding that out the hard way. Installers for their new build are totally booked out for months. So I'm going to leave you with this to chew on. We know the weather is always going to throw curveballs, but the long-term data absolutely proves this technology works. And we also know for a fact that gray electricity rates are only going in one direction, up. So the real question isn't whether solar panels are completely perfect. The question is, with everything going on, can you afford not to calculate your own potential savings? Take a hard look at your bills, check out the incentives in your local area, and see if achieving true energy independence is the right move for you. Thanks for hanging out with me for this explainer, and keep learning.